Question 2 says sodium carbonate reacts with hydrochloric acid in an exothermic reaction. Exothermic means it gives out heat. What will happen? The temperature will increase. Then it says the equation for the reaction is given to you here. You've got sodium carbonate. When it reacts with hydrochloric acid, it produces sodium chloride, carbon dioxide gas, and water. It says a student investigated the effect of changing the mass of sodium carbonate powder on the highest temperature reached by the reaction mixture. Now, this statement is very important because it is telling us that you will change the mass of sodium carbonate. And it says on the highest temperature reached, so I can say highest temperature reached will need to be recorded. It says plan a method to investigate the effect of changing the mass of sodium carbonate powder on the highest temperature reached. And for this investigation, we'll have to plan a method. So let's start, and before we start writing our method, we need to identify what are the variables which we will have to keep constant, meaning control variables. So we've already identified two. This is my independent variable. This is my dependent variable. So I can say number one, independent variable is my mass. Then I have dependent variable, and this will be my highest temperature. And then I've got control variables. So if I go back and have a look at this equation, I know I'm changing the mass here. I need to talk about the volume and concentration of hydrochloric acid, as well as the starting temperature of the hydrochloric acid. So I'm going to say T start. Number two, I can say here volume of HCl used. And number three, I will say the concentration of HCl used. So now we've given them a clear picture. What is it that's going to change, and what is it that will be recorded, and what is it that will need to be kept constant throughout the investigation. Now we can write down our method. So first of all, I'll say record mass of sodium carbonate using balance. Number two, because we are talking about the volume of hydrochloric acid used as well. So we'll have to say transfer, let's say 50 centimeter cube of HCl to a beaker using measuring cylinder. And let's say record temperature using thermometer. This will be our T start. And then I can say transfer Na2CO3 to the beaker and record T max. I can say number 4, to find delta T, which is change in temperature. We will do T max, take away T, start. Once I've done this, I now need to tell them that they can't just do this experiment once, because it says effect of changing the mass. So I'll say repeat step 1 to 4 using different mass of Na2CO3, and this will get us full 6 marks on this question. So you can see questions are fairly easy, and most of the answer or a lot of hints are given within the question. So you just have to make sure you read the question carefully. This figure 3 shows the line of best fit drawn through the student's results. It says determine the gradient of the line of best fit in figure 3. It use the equation change in highest temperature over change in mass. And it also asks you to give the units. Remember, change is always worked out using final takeaway start value. So we'll have to work out the final value of the temperature and we'll take it away from the start value. We'll do the same thing for the mass. We will do the same thing for the change in mass. We'll work out the maximum value of the mass and the minimum value of the mass. And for this, you have to use the figure 3. So what I'll do is, in this case, I'll change this line into a triangle. I've converted this line, straight line, into a triangle. And now from this triangle, if I work out the base will be my change in mass. And the height will be my change in temperature. In this case, you started at 1, you went up to 5. So the change in mass will be 5 take away 1, which is 4. In case of change in temperature, your value here is about 22.2. And the value here is about 28.6. So you'll do 28.6 take away 22.2. And this gives you an answer of 6.4. Once you've worked out these values, all you have to do is just plug in this equation and you'll figure out the answer. So I can say my gradient will be equal to 6.4 divided by 4. And if you put it in your calculator and solve, it will give you an answer which will be 1.6. Now it does ask you for unit. And if you look at it, for the numerator, it is the temperature. For temperature, the unit that has been used here is degrees Celsius. So I can say the unit will be degrees Celsius divided by the unit for mass was grams. So it will be 1.6 degrees Celsius per gram. Next part says the initial temperature of the reaction mixture is where the line of best fit would meet y-axis. Determine the initial temperature of the reaction. So the line of best fit, the line of best fit would meet the y-axis. Asks you to determine the initial temperature. To work that bit out, what we will need to do is we'll have to extend the line backwards until it crosses the y-axis. If I extend this line backwards, it will cross the y-axis here. If I look at it, the value here is about 20.6 degrees Celsius. This is my T start. So the answer for this question will be 20.6. Next part says another student repeated the investigation but added sodium carbonate until the sodium carbonate was in excess. Which sketch graph shows the results obtained when sodium carbonate was added until in excess? Now you have to remember one thing in this case. As you'll add more and more sodium carbonate, the amount of acid will keep on decreasing. So your reaction will slow down. And if your reaction slows down, that means the temperature increase will also fall. This is wrong because this part is incorrect. In this case, there is no change in temperature taking place. Again, this is not right. In this case, what is happening? The temperature keeps on increasing. And at this location, what has happened, I can say my reactants, I won't say reactants, but I'm going to say reactant, which is HCl, is no more available. So in this case, my answer will be this because there's no more change in temperature taking place, and therefore I can say this is my answer. For the next part, it says figure 4 shows the reaction profile for the reaction of sodium carbonate with hydrochloric acid. It's an energy profile diagram. You have to remember here it is always energy. Says what do labels X and Y represent on figure 4? So X is my energy. And if you remember, recall, this is your E released. And this is your E supplied, also called activation energy. Now this, if I look at it, it's the difference of them two. So this is my net energy released. So all I will need, so all I have to say is this Y is representing the net, or you can say overall energy change. Last part says, how does the reaction profile show that the reaction is exothermic? So if the reaction is exothermic, your E of products will always be less than E of reactants. And this is the case in this case because my energy of products is much lower than the energy of the reactants. Therefore, it is exothermic